Okay, so today we're going to have a look at using test coverage to improve your testing. Inside VIP, you will see a little leaf here which contains lots of different activities you can use to create covered sets or combinations of data that can then be used to drive testing. If you go in and type test coverage into Google or Bing or whatever, you'll see lots and lots of articles on it. The Wikipedia one is reasonably good. Basically, it refers to measuring how much a software program has been exercised by test. Coverage is a means of determining the rigor with which the question underlying the test has been answered. There are many types of test coverage. We will also be having a look at, if you take a look at testcover.com, it's a service that we can actually call out to. So if you're a subscriber to testcover.com, we can actually call that as part of a VIP flow. It's got some nice examples in here as well. So let's just go and look in the folder. Now the folder we're looking at is the examples coverage. Now there's quite a lot of stuff in here. So the first things first, let's just open up a basic pairwise flow like so. Looks pretty straightforward. Now what we're actually doing here, if we just go back, is we're actually using we're making a call out to a thing called picked, and if you just open this, you'll see a description of all of the different types of parameters, and it's a little inscrutable, but once you actually get going with it, it's actually pretty much okay. You can put conditions in, you can put criteria in, you can have pairs, triples, quadruples, etc. You can do negative testing, etc. So we've exposed that as part of VIP. So let's just take a quick look now. Also within here you will see a thing called a word font.txt. We'll just have a quick look at that. Now what you're seeing here is that we're actually going to be looking for combinations of fonts, style, size, color, underlined, etc. We've also got a criteria in. If it's times, then the style is regular and the size is 10. So we're forcing some values in there like so. So this is how you would drive the pairwise tool. And if you come back in here, you'll actually find we're actually using somewhere in here we've got basically using the actual par file, and then when we've passed it as an argument, here we go, word font.txt. Okay, now just as an FYI, there's actually two different methods we're using here. I've just set an arbitrary decision 1 = 0, so it's going to come down this method, and you will see here the name of the file, the order of combinations. So I'll just set that to 2, so we create what we call paired combinations. You get every single pair, and then we're going to do a for each, so we'll just run that. And you'll see here that we're actually creating, so you're going to end up with an Arial and a bold, an Arial and a regular, an Arial and an italic, and so forth. So basically every paired combination of values is matched up. If you come in and change that to a triple, like so, that is going to make sure that every triple combination, now there are, as we saw from the file, let's have a look here, there are about 17 different types of variables in here, so the triple is going to make sure that all 3 of them are actually included. So it takes a second to run this one, and you get a much bigger list if you go through using the triple. Just as an FYI, the reason that there's 2 different methods is that we've actually created a model. Later on we'll teach you how to use models. Now the advantage of using a model is it's faster because you're using memory, Windows memory, much better. And also when we're actually displaying the outputs, here we've got, you'll see we've actually had to pull out the item and give it the names which is being returned in the collection. So we actually have to remember the names. Whereas if we go down the left hand side here, you'll see that the names are actually included in the item. So if you're using IntelliSense, you could actually then just go through and find item.font, etc. So the property has come from this model. Okay, so there's 2 different approaches. We'll get to it later, but hopefully you can see that's how easy it is to use, and all you're really doing is just playing with this particular file which you're sort of manually creating. Now the next thing I'm going to show you is a similar concept, but in this case we're actually going to pull the data in from a database to start with. So let's take a look at the parameters. So you can see from the parameters we're actually passing in, let's just look over the direction here, we're passing in the columns we want to look up. This is actually the connection into the database. Now you'll see I've got warehouse.name, tax category name, currency, currency code, shipping method, etc. And all I've done is just taken the table names, dot column name, and we're going to put in a distinct value of those. Just set that to 2 for the moment, just so we can see what's going on. So if you just go and look in the database, this is the NOP database, and you'll see here we've got, for example, tax categories, we've got warehouses, and what we're going to do is try and create combinations of those. So when we're testing, creating a bunch of orders, etc., we're going to make sure they're spread around using the coverage techniques. So let's go off and now, so if you take a look at this flow, we'll actually look at this flow in a little bit more detail. Well, first thing we do use a nice thing called split string. So it's worth you probably having a read through this flow because it's got some good stuff in it. So you've got split string here. So separator is a comma, and that's going to put it into var table column list. And let's just have a look at var table column list, which is a string array. How many columns? So here we're saying if you're using var table column list dot length, which is telling us how many we'll put into the array. If it's 0, it just puts out an error saying you're not actually telling us to do anything. Here using a while loop, and if you look in the while loop, you'll see we created a variable var I, and if it's less than that, and then within that we're actually just assigning the tables and the contents. Okay. Now what we're doing with the tables and contents then is we're then going to let's have a look in here. We're basically, so you can see we're using var I, like so, and then we're actually going to load a data table, and you can see we're issuing a select distinct var column and var table, which have come from our split, which have been passed into these variables, and then we're reading through for each data row, and we're adding in the content here. So we've got var data table.select, so we end up with item, and all we're doing here is we're putting in the values that we're returning from the data table. Item 0 is the first value, and there is only one value in this case, toString with a comma in the front. And what that's going to do then is if we go back up to here, let's just move back up a little bit. So that's in effect creating, it's going to create a file called work.txt. So previously we actually went off and created word font.txt, but internally here what we're doing is we're actually creating a little file which we're then going to pass on to our pairwise tool, our pairwise activity, like so. So all that really is doing is just creating that. So it's a nice little bit of a flow. Just have a quick look at it. We're doing a log of it. We're doing a write text to file, which is actually going to just put it file path, which you'll see is work.txt, and then we're just going to now in this case what I'm actually saying is just return the control file, because you might want to merge this with some of your own types of other types of activities, you know, in addition to the database activities. And then what you would do then is just merge them together and run the pairwise yourself. Alternatively, here what I'm doing is just passing our way down, and we're using exactly the same pairwise tool. We're putting it into an output collection, and then a collection. In here, actually what we're doing is, just take a look, var string, let's just have a look at var string. So here what we're doing is we're actually taking the values from item.key. So item.keys with an increment, so as we're pulling the data in, we don't know what the values are, we're not worrying about them, we're just pulling them blindly and putting them back out into there. So this is kind of a nice trick to be able to make it more generalized rather than having to know the names of every one of the columns. So and then we're down there, and then we're writing the results file, and the results file is going to a thing called results.csv, which we could then pick up and use to drive the test. Okay, so if I just run this, so that's gone through and it's created a paired set of data. This is the data it's reading, like so, and then it's dumped the data into our little file. I've just actually printed it out here, and then it's gone off and used the seed methodology. So, sorry, it's used the pairwise, and it's using just paired, I think, with number 2. And what you'll see also in here is, if we just open that, that's actually put that out into a little spreadsheet, and there's 60 different variations on them. You'll also see in here a little thing called settings.xml. If you just open that, actually, when you're running VIP, you'll see you only get the last 100 log items. They're actually the full log is actually pulled out into log.log in the output folder, but you can override that by just putting a small file in here called settings.xml. So if we just open that, you'll see settings.xml basically is just telling us to display a thousand lines in the log. Sometimes that's a little easier. You can just move that around or just set it to whatever you want inside there. So let's go back to VIP. If we set that now to 3, we're going to go off and get some triples. Let's just go and get some triples here, and we're going to execute this. And you can see for the combined values there were 180 combinations. You'll also see at the end that I'm actually passing the values back. This is the control data, which is the work.txt file, and also I think the results are actually coming back in as well. So you could just make a call out to this and then read the par results to yourself rather than using the CSV file. So hopefully you can see that's pretty straightforward. And the next thing we're now going to do is move on to the test cover, the call out to the test cover flow. In this case, what we're going to be doing is we're going to be making a call to the test cover WSDL, and if we just go out to test cover, you'll see in here there's the WSDL interface, and all we're doing is we're actually going and making a call to an external service to create our control file. Test cover is a pretty excellent tool, so feel free to have a look at it. It's paid on a subscription basis, and then the actual creation of the coverage will then be returned to you using a request response pair. So let's have a look at the flow itself. So first things first, let's take a look at the read file content. Now what we're doing here is we're actually reading in a thing called request.txt. Let's just have a quick look at that. So here's request.txt. We'll just open that. Now this has basically come from this first bit has come from the definition of the WSDL, which you can have a look at, and then what we're doing here, which is my account, and then basically what you do then is you have to create an XML structure. Now in this case we're just showing you how to do that. What you would actually do is probably build this up based on maybe a similar way to where you get the data from databases, etc. So we're reading that in. Then we're invoking a method, so we're actually sending a request, which we've just read in. We're getting a result, which is a response. If we just hang over that, you'll see, let's have a look at that, like so send request, the object, the type is task automation raw SOAP request. We're going to invoke that method, and let's have a look at this. There's this one here. We're going to now invoke the method where we're going to load the XML. We're going to bring the XML back in into a response doc, and response doc is, let's have a look at response target object. Response doc is an XML document which we've just set up like so. Then we're going to get test case response. Now we're looking at, let's have a look inside here. So there we've got get test case response as system XML node. That then gets the response doc back in, and then what we're then going to is write that text to a file. So that's going to the file path is file response file, which is the response.xml. Then what we've got in here is we're doing some deserialization. Again, you don't particularly have to understand this for the moment. We will be covering how to deal with request responses in a separate email. But the result is you get your test cases, and then we've split them up. And in this case, actually, what we're doing is we're calling a subflow in here, which is then going to display the results. So let's just have a quick look and run this, and let's just action execute. And that's gone out to an external service. We're using obviously a static XML structure here. You would most probably make that dynamic, and that's now done a request, done a response, and brought it back in. So if you're using test cover, you can pretty much use this as is, and then all you need to do is manipulate the XML at the beginning. So that's test cover. So now let's take a look at some of the activities in the coverage folder: permutation, permutation set, combination, and power set. It's probably worth you just researching them a little bit, there's a couple of nice websites, Better Explained Easy Permutations and Combinations, which talks about some of the differences, and then Power Sets, which is the last thing I'll talk to you about. So I may refer back to these websites, but certainly bring them up and have a look around. So what we're going to do is open up Permutations and Combinations flows. Now this is a nice example, and basically what you should do is just kind of get your head around each one of the different types and see which one's appropriate for your particular test coverage you're interested in. So we'll just start with a simple one, which is permutation. I'm just going to just take that off there for a minute so we just have a look to see it run, and let's just execute it. And this is a list of permutations. Now what have we got going on in here? So so what we've done is we've just dragged permutation onto the palette. It's an integer, and looks at the properties of that. You'll see permutations with some input lists and lengths and output lists, etc. So let's just get rid of that and look at the variables we've created. So you'll see we've created an item which is a list, and this is pretty much going to drive all of the examples. So we've got a new list of integers 1, 2, 3, 4, 5, and that's what's going to be. If we go back to permutation, you'll see the input list is items. Okay, now we've also got a thing called var length, which is the length of the list that we care about. So here we've got it set to 2, and we'll play with that in a little minute. So if we just go and run this, so we've got basically there are 5 possible. So go 1, 2, 1, 3, 1, 4, 1, 5, 2, 3, 2, 4, 2, 5, 3, 4, 3, 5, 4, 5. So no surprises there. Those are the different permutations that are available. If we just play with the variables slightly and just set that to a 3, what you'll see there is now we should get a bigger list. 1, 2, 3, 1, 2, 4, 1, 2, 5, etc. So this is just basically coming up with the standard permutations that are available for 3. If you put 5, obviously you get all 5 combinations. Just pop it back to number 2. So that's what the permutation one's very straightforward. We'll just tie this back together again, and now we'll move on to get permutation sets. Now the permutation sets, let's go and have a look. Permutations is actually going to deal with the issue of ordering. So let's have a look now, and again I'll just take that one off so we just have a look at this. So now the permutation set here, 1, 2, 1, 3, 1, 4, 1, 5. Now we've also got the order, so we're starting with the number 2 and 2, 1, 2, 3, 2, 4. So if the order of an activity is important, then you need to use a permutation set, like so. Again, if we look at the arguments, sorry, the properties of this, you'll see item, the length, and the out list. So there's, you can use permutations or permutation set. Permutation set is going to give you the ordering as well. So it's obviously going to come up with a bigger set. So let's just go back and just turn the variables off and just attach this on now. So that's permutations. Now we're going to get into combinations. So let's have a look at combinations. Again, popping back to combinations, different types of combinations. Those are very straightforward. Let's just go through combinations for each log activity. I'm just going to take that out like so. Actions execute. Combinations 1, 2, 1, 3, 1, 4, 1, 5, 2, 3, 2, 4, 2, 5, 3, 4, 3, 4, 3, 5, 4, 5. Now it's probably worth you having a quick look at the website where you get a description of what combinations are. Order doesn't matter, you can mix it up. How many ways can I give 3 tin cans to 8 people? Well, in this case the order people doesn't matter. If I can give a can to Alice, Bob, and then Charlie, it's the same as giving Charlie, Alice, and Bob. So that's basically what the combination does. What we're going to do now is move on to sets of combinations. So we're actually going to create some sets. Now what we've done here is for the combination list, previously for a combination we had the properties var out list, or sorry, input list was items, which was the list we looked at before, which is a simple list. But if we go into a combinations here, in this case what we've done is we've taken the output from the combinations and we've now pushed them into as inputs into the same activity. And again, let's just put that one off like so and run this. And see, what you'll see is you'll get sets of lists now. So if you scroll up a little bit, so again these are the different potential list set combinations. Okay, so that's a kind of a more advanced method of being able to build sets of lists. So again, that's that one. Now the final one is a thing called a power set. Now this is kind of an interesting one. It's probably easiest shown with a little diagram here. So if you think about X, Y, and Z, what we're actually doing is if there's no X, Y, and Z, it's a zero, then you could have an X on its own, a Y on its own, a Z on its own. You could have an X and a Y together, an X and a Z, a Y and a Z, or finally you could have an X, Y, and a Z. So that's what that is. Now, in this case, if you looked at these activities, combinations, we were using the var length, which pretty much we're using 2. When it comes to the power set at the end, the power set doesn't have that combination because it's just basically going to give you all of the combinations that exist for uh, all 5 in the list. So basically we have a quick look at that one as well. So that's run, so let's just have a quick look. Now you can see the first list is actually empty, which is predictable, so that's no 1, 2, 3, 4, 5s. Then the next one's just got a single 1, a 2, and then 1, 2. And as you work your way down, you'll actually see then at the bottom you've got 1, 2, 3, 4, 5, which is kind of has all combinations therein. So hopefully you can see that by using these very powerful activities in here, you can improve your testing by driving through richer sets of data by using all sorts of different combinations. That's it for today.